So, my name is Arvid Breitenbach. I work on image processing software for inspection machines at a company called Seidenader, located in Markt Schwaben. And my talk is about graph-based analysis of include relationships. If we start with a code base and see the... no, that is the wrong one. Oh, wonderful. I got the wrong one. Let's see whether I have the right one as well. Sorry for that. So, let's try this one. Now, if you start with the code base and consider source files and headers to be nodes and to include relationships as edges, then you have a method for constructing graphs. For example, you get these graphs pretty easily. This what you see here can be generated from Doxygen with little effort. And if we look at greater code bases, then we get bigger graphs. And for these, it might be a good idea to combine matching CPP and H files into single nodes. Now, why did I do all this? I wanted to examine a code base that was, well, not quite as good as you might want it to be. And this had one project which was, well, it was big. I'll just call it the monolith. And I created a graph for this fairly big project and used YAD as a graphing software to look at the graph that I got by this. And from this I got some hints on how to clean the mess up. Now this is the monolith. It's not beautiful. It looks back, as you've seen at the previous slide, on decades of cancerous growth. And if we zoom in a little, well, it's still quite ugly. Now, what can we do? What we would like to do is separate out some groups of files. We can do that if we play around, or we can get hints on that if we play around with our displaying software. We're looking for portal nodes like the one that is circled, so as to have a way or get points on where to remove code or files from the project. And of course we look for header files that are included everywhere. These are usually monster header files, so we split them and reduce their use. We rinse and repeat. And when we do that, well, it's not exactly beautiful, but it's a little less ugly than it was. And if we do that a lot more, we get something, well, at that stage we have moved out quite a bit, and now I would like to explain how we move things out. For example, the node that is circled in red, which is not very well connected to the rest of the project. To do that, we look at the entire code base, all the nodes, all the links, and all the projects. Unfortunately, I don't have time to explain my coloring scheme. But if we look around such a graph, we see things like this, where we have a group of files that are not connected to each other and not connected to anything else in their project, so they might probably want to be elsewhere. So we need to look at that. Getting back to the node we want to move out, we see here that its dependencies are spread pretty widely over our code base. So just looking at the big graph won't get us that much further. So we look at a subgraph, just the neighborhood of our node. And here we have a hierarchical view, left to right. The brown one is the node that we want to move, and we probably want to move it into one of these projects that contains neighbors of this node. But we don't want to introduce new dependencies. So we look at the dependencies that we already have. This is now a graph of projects, and the weights of the arrows are the number of include relationships between the projects. So, and looking at the hierarchy, again, left to right, we see that the project we want to move our node into is the one circled in red. But where exactly there? Here we look at the neighborhood of the neighbors of our node that are already in this project. And we see there are 3 of them, and in that node, in that project, sorry, there is already one node that is parent to all of the 3 red nodes. So our node that we want to move should probably be included by that one. So we try that, and it works quite well, and our node seems to be much more at home in its new environment than it was in the old one. Here it's really linked to many others of them. So, what do we gain by looking at complete inclusion graphs? We get a different view of our code base. We see the full include structure at one glance. And if we zoom in or look at individual projects, then we get further glances. That hopefully will help us to rearrange source files between projects. Thank you very much. And I think we have time for questions. Yes, please.
Is it all done by hand, or do you know any tools which automate?
I've written a few tools myself, but I'm unaware of any tool that does something like that. So if anyone knows a tool that does what I'm doing here with some effort, I would be glad to learn about it.
So maybe you're aware of just LLVM-based tools like include what you use and tidy, which also able to remove header files from sources and just forward include the symbols defined there.
But they don't give me graphs to see what they experiment. They experiment with the includes and see what works and what doesn't.
Yeah, but this information is stored in the build system, so maybe.
Okay, might be worth having a look at that. Further questions? No? Thank you very much then.